Are you tired of failing your organic chemistry tests? Struggling with grasping all the daunting tasks of nomenclature? Or feeling overwhelmed by the amount of memorization? Well, memorize no more. Turn that F into an A with the help of our new program, Nomenclature Made Easy.
Hi. Now that you've mastered the basic of unbranched and branched alkanes, we'll introduce cyclic alkanes and alkyl halides. Last episode enabled you to name alkanes while following a tutorial, and this episode should allow you to name these molecules from the comfort of your own home.
Alright, well let's get comfy.
We will continue to follow the International Union of Pure and Applied Chemistry, or IUPAC, nomenclature of molecules. Remember that naming is one of the most important skills to have in organic chemistry because there are millions of known organic molecules and scientists must have a standard for identifying each. Once you understand the nomenclature rules and how to apply them, you can name pretty much any molecule you come across. So, to start off, we'll discuss the basics of cyclic alkane nomenclature in general. First, recall that all names of alkanes end in the suffix -ane and are always comprised of solely single bonds. For compounds with a single ring, the prefix cyclo must be added to the root name. Here's the table that you should remember from the previous episode. This corresponds to the number of carbons that are comprised in your molecule. Have you created a table such as this in your notes?
Of course I have.
Way to be a proactive poly. We will now follow the same steps as labeling branched alkanes. First, using the drawing by my lovely assistant, whose identity will remain anonymous, identify the parent chain. This is the longest chain of carbons in the molecule. If the parent chain is longer than the ring, then the ring is a branch, and cyclo precedes the name of the substituent. So, is this ring a substituent, or is it the root?
The ring, and it's cyclohexane because it's 6 carbons.
Yes, the answer to that question was a cyclohexane ring. Now we can go on to step 2 and identify the substituents and their location. We can see that there are 2 methyls and 1 ethyl, but how do we know where to start labeling them?
I'm not sure. Is it methyl because it's bigger?
Right you are. We begin labeling by starting with the carbon that has the bigger substituent and follow the ring to the next closest substituent. So, where are the substituents located?
Carbons 1, 3, and 4.
Exactly. So now we can put together the entire name, remembering our rules from last episode. Substituents are named in the same fashion as the parent chain, except they end in the suffix YL instead of ane. This indicates that they are a group connected to the parent chain. We have 2 methyls, therefore dimethyl will be included in our name. To sum it up, we have 1 ethyl, 3,4-dimethyl cyclohexane. Now that we know how to name cyclic alkanes, we can move on to alkyl halides. This method will be the same as naming branched alkanes. The only difference is that instead of a methyl or ethyl group, we will focus on a halide as our substituent. The prefixes on the board as follows. Go from fluorine to fluoro, chlorine to chloro, bromine to bromo, and iodine to iodo. In this example, we begin by naming our parent chain. What's the parent chain?
Yeah, pentane. I got it.
Yes, pentane is correct. We label in the same fashion as before, making sure the substituent is on the lowest carbon possible. So, our chlorine is on locant 2, which means our name is going to be 2-chloropentane. Okay, but how do I know which comes first when there's a methyl? Is it the methyl or the halide? I don't usually answer questions from a viewer at home watching my program, but that is a great question. We see here that we have a methyl and bromine attached to the parent chain. Alkyl groups always take precedence over methyl and ethyl groups. Therefore, the name of this molecule is 2-bromo-4-methylpentane. Thank you for asking. Thanks for tuning in. That sums up episode 2 of Nomenclature Made Easy, the naming of cyclic alkanes and alkyl halides. For more fun, watch episode 3, the naming of alkenes. Remember, it's for all kinds of people.
Look inside your tiny mind and look a bit harder, 'cause we're so uninspired, so sick and tired.